Thanks everyone for joining the session. Today I am going to discuss about OSPF adjacency process, which is very important. Okay, so OSPF adjacency means to complete, the complete process, like how they will discover the neighbors, how they will exchange the neighbors, okay, and then how they will calculate the routes and put in routing table. Okay, so ultimately OSPF used to learn the routes, right? So once you configure the command router OSPF, you know, some process ID, then when you start advertising the networks, right? When you start advertising this network, the network which is there on the link 192.160.1.0, right? The network which is there on the physical link, right? Once you start advertising this network, OSPF router R1 and R2, how they will behave. Let's understand. Okay. So, guys, we have total 7 states, OSPF states. There are a lot of states to complete this process. So, there are a lot of states to complete this process. Once to complete this process, this entire process is called OSPF adjacency process. Okay, na? Yeah. Now, like each and every protocol will have a headers, right? Yes or no? So, same way,
Yes,
OSPF have headers. OSPF protocol itself is having a header. So OSPF is a layer 3 protocol, right? So you will see it is a layer 3 payload. It means after IP header, you will see this OSPF headers. Okay. Now OSPF have 5 kits. OSPF header is a boss and he has 5 packets. So how many packets we have in OSPF? Hello packet, DBD packet. It means database description packet and a link state request packet, link state update and acknowledgement. Very important. 200% they will ask you in interview. How many packets we have? 5 packets. You know what these packets will do? These packets will help you to complete the adjacency process. Okay? It will help you to complete the adjacency process. But the thing is, at what time these packets will come and help? That is important. So generally OSPF has a 5 sons. Each son have his own responsibility to fulfill. Okay, just remember like that. So hello packet. Okay, hello packet. Okay, na? So let's talk about step by step process. Okay, once I configured a OSPF on this router, right? Okay, my router. So consider this is a R1 and R2 and Hyderabad location, Bangalore location. Okay, just consider that. Okay, na? And these are the R1 R2. If you configure OSPF, what will be the steps? So once you configure a OSPF on R1, so R1 the first state is down state. So in down state, you haven't configured any OSPF. Okay. Once you configure this OSPF right by using network command and all, immediately router 1 starts sending a hello packet. Is that router 1? Router 1 will start sending a hello packet through what? Through multicast. Through multicast address 224.0.0.5. It means this 224.0.0.5 is reserved for OSPF. It means for all routers OSPF. It means all routers are belongs to one group. Which group? This multicast group. Guys, understand what I'm saying? Hello, you got it?
Yes, sir.
So there are some group. How to represent group of persons in layer 3? You need to assign an IP. This is called multicast. Multicast means one to several, right? So yeah. So once you configure OSPF on your router, so router 1 was in down state, so immediately it will start sending a hello packet through multicast address 224.0.5. Now tell me what is the source IP? It is generating a packet, right? Hello packet. So let's generate entire packet. What is the source IP? R1 is sending to R2. Please tell me.
1.1.
Very good. 1.1. What is the destination IP?
Multicast IP.
Very good. Multicast IP. They will send it, I said, right? They will send it is a multicast, not unicast. It is a multicast. Okay. And now you'll see IP head. This is IP header, and you will see the OSPF header. So in the OSPF header, you have a lot of important fields. What are the important fields you have? Main version. We have two types of version in OSPF. Version 2, version 3. Version 3 supports for IPv6 also. Consider here it's a version 2. Okay. Now router ID. Very important. So lot of people will confuse with router ID. Now I want to clarify it now. So this R1 have a host name of Hyderabad. Why we are giving Hyderabad as a host name? For human understanding purpose, right? By logging on the device, you will see host name is Hyderabad. You will come to know, okay, this is Hyderabad router. But how routers will have a name? They cannot understand alphabetical, right? Hyderabad is an alphabetical thing. They cannot understand it. What they will understand? They will understand zeros and ones. What they will understand? They will understand only zeros and ones, right? So how router will choose his name? Guys, మీకు అర్థమవుతుందా నేను చెప్తున్నాను? So routers cannot understand alphabetical things. They can understand zeros and ones. Now, router internally itself, he has to choose his name in the form of IP address. So, router will choose its name in the form of IP address. Just in the form of IP address. Ante. IP address form లో ఉంటుంది. But that doesn't IP address. Okay. So how it will choose is its name. That name is called router ID. RID, router ID. Router ID is what? Name of the router. Is it clear? Okay. How it will choose the router ID? In case if you configure loopback IP address, right? It will choose that loopback IP address as the router ID. In case if you configure multiple loopback addresses, right? Okay, two or three. So you can see highest loopback IP will be the router ID. Just name of the router. In case you did not configure a loopback IP addresses, definitely you will configure a physical IP interfaces, right? Yes or no? So that physical interface IP will be the router ID. So the router it will choose its name in the form of IP address in this hierarchy. Understand everyone? Hello. So now my R1 router loopback IP is 1.1.1. So what could be the router ID now? What will the name of the router? It is
1.
1.1.1. It is not a IP address to carry the route. So it is not a route, guys. It is just a name of the router. It just represents in the form of IP. That's it. Is it clear? Is it clear about router ID?
Yes, sir.
Yes,
So
sir.
now router ID is 1.1.1. Now after that you will have a area ID. What is the area ID? It is area 0, right? Now you have a area type also. We have a types of areas like stubby area, not so stubby area like that. Okay, that I will teach you later. Last. Okay, area type should be match. Okay, now then authentication, authentication type and data. So authentication type we have a null authentication, encryption like that. So unnecessary people also will join this group and become a neighbor. So to protect that, you must give authentication. Okay. So this is a important thing in OSPF header. This is a OSPF header. Whatever you seeing, right? This is a OSPF header. Top of that, what you will see? Hello packet. So you will see top of that you will see hello packet like this. In hello packet, you have a lot of parameters. I will teach you later. That is not an important right now. Okay, it will carry the hello packet also. Top of this, you will see hello packet. See, this is a packet architecture. So here, the first packet is zeros and ones, then MAC, and then IP address. Since we are talking about OSPF, right? I started with source IP and destination IP. Is it clear? So this is the IP header and it will carry the OSPF header. And in this, these are the important fields in OSPF header. Version, router ID, area ID, okay, area type, authentication type and data. Okay, very, very, very important, guys. So it is already described in OSPF class. Okay, PPT. Okay, so just go there and complete the basic OSPF. See, this is a OSPF common header. So I'm going to give you after the class. Please prepare it. Very important. Version, router ID, area ID, authentication type and data. Remaining all are common fields for each and everything, each and every packet. Okay. So please prepare it. Okay. Yeah. Now this hello packet will go to R2. So are you following me, everyone? నన్ను ఫాలో అవుతున్నారా?
Yes, sir.
అర్థమవుతుందా?
Yes, sir.
Yes, sir.
Yeah. Now this R1 is sending a hello packet to R2. So now R2 received it and sees, hey, I'm also a OSPF. And what it will do, it will check all these parameters. All these parameters should be matched except router ID. Router ID means name of the router that should be unique. It should not be the same. Definitely router ID should not be the same. It should be unique. So remaining all parameters should be matched. Okay. R2 receives this hello packet and match all the parameters as per requirement. And then R2 what it will do? Hey, your OSPF router, I'm OSPF router. And and you whatever the parameters you have, right? I have the same parameters. Same thing is matched. So now you are my neighbor. So router will send a hello packet. In that hello packet, you will see active neighbor field. So so R2 receives this hello packet and confirms that after matching all these parameters, okay, I'm announcing you are my neighbor. So who is announcing this? R2. What it is announcing in a hello packet? Hey, in hello packet you have a one field. In hello packet we have a one field called active neighbor field. In that active neighbor field, it is activating the neighbor field. It is activating the neighbor. So who is your neighbor for R2 here?
R1.
What is the name of the R1?
1.1.1.
That's it. So the R2 will add the R1 router ID. Okay, because it receives here, right? Received it and it will add the R2 router ID. Ardhamainda, everyone? Hello.
Yes, sir.
Now this packet will go to R1. So let me tell you once again. Once you configure a OSPF on your router, R1 starts sending a hello packet with this all parameters and it was in down state. Once you configure right, immediately it will send a hello packet to R2 through multicast address and it moves from down state to initialization state. After configuring OSPF, immediately it will send a hello packet and jump into initialization state. Okay. Now in initialization state, it is waiting for a hello packet from R2. Okay. Now hello packet is received. And once it receives the hello packet, it sees its own router ID. Yes or no? In active neighbor field, it
Yes.
sees its own router ID and it will celebrate it. Hey, I received a hello packet from R2 and I can see my name in this list. So it means R2 is recognized me. So immediately it will go to two-way state. Understand everyone? Hello. Everyone understand?
Yes. Yes, sir.
Okay. This is R1 direction. Similarly, there will be a R2 direction as well. So same R2 also will send a hello packet to so R2 that is R1 perspective and same way this is R2 perspective. That is R1 perspective. This is R2 perspective. So R2 send a hello packet to R1 with multicast address. Same thing. Here router ID will be 2.2.2. It's the same thing. And now once it is receiving right, our R1 will send a hello packet, right? To to R1 will send a hello packet to, come on guys, after matching all the parameters, right? So R1 receives this hello packet from R2. Now it matches all the parameters and recognize R2 as my neighbor, right? So now in the active neighbor field, what it will mention here.
True.
So everyone understand, all 40 people? Everyone
Yes.
understand this?
Yes, sir.
So initially, both the routers will exchange the hello packets and move to initialization state. In initialization state, the routers will receive a hello packet from the neighbor and sees its own router ID in active neighbor field. Okay, and then it will move to two-way state. And R2 also will do the same thing. So in two-way state, what will happen? The neighbors are discovered. Yes or no? The neighbors are discovered. Yes or no? In active, both the neighbors are discovered. Now here you can run show IP OSPF neighbors. You can see the neighbors. So in interview they will ask you, okay? In interview they will ask you in which state the neighbors are discovered. Two-way state. Is it clear, everyone? Hello.
Yes, sir.
Okay. Yeah. Now interview questions and troubleshooting steps as well. I'm teaching you in live. So in case if these parameters, any one of the parameter is mismatch, so the OSPF will stuck in which state?
Two state.
Very not two-way, ma. Initialization.
Initially,
Yeah, because you sent a hello packet to R2. R2 and then immediately it will move to initialization, right? And then R2 received it and the packet is not matching. So R2 is not sending a hello packet with a neighbor field. So it's still in initialization state.
okay.
Initialization state, when it will go after sending hello packet, immediately it will go to initialization state, right? Yeah, it is waiting for a hello packet from R2 and it sees its own router ID. Until unless it sees its own router ID from R2 hello packet, it will not move to two-way. So it will stuck in initialization state. Okay. Yeah. Please remember. Okay. Yeah. Now, shall we move to the next state, extart state? So till to discover the neighbors. Who helped us? Hello packet. The first
The
cell.
packet.
The first packet, hello packet. Now, first hello packet responsibility is completed. What is the next packet? DBD packet. DBD means database
Database description.
description packet.
Description packet.
Very important. Now, after discovering the neighbors, remaining packets are multicast or unicast? You just tell me. They discover the neighbors and it's done. Now it is unicast or multicast?
Unicast. Test.
Unicast. So DBD packet is unicast. They will talk one to one now because then discover the neighbors each other. Okay. In extart state, what will happen? The master slave elections will happen. What do you mean by master slave election? See, what is the first step of routing protocol procedure? It will discover a neighbors. And then after what will happen? They will exchange the routing information. Yes or no? Hello?
Yes.
Right?
Yes.
I said
Right.
in OSPF you will see databases, right? Link state databases. Yesterday I told you, right? Link state databases. Hello?
Yes, sir.
Yes,
Right?
sir.
So link state database, it means the router will maintain a database that will be equal in each and every area. Okay. So that is a so that's why it is a link state database routing protocol, right? So whatever the routers in the area, everything will be syncing. It means R1, R2 is belongs to area 0. How many routes are there in R1? Same routes will be there in R2 also. So it means they have to sync each other, right? So that syncing process, the database syncing process will start in extart state. Okay, the database synchronization process will start in extart state, and this R1 R2 are fighting each other. Hey, I want to send my database first. R1 is saying that no, I will send the database first. Please go on mute. Please go on mute. Anata. Okay, I I kept you in mute. Okay, fine. You understood, guys? You understood in extra state what will happen? The database synchronization process will start. So that's why they are fighting each other. I want to send the database first. So to control that, there is a discipline, right? That's why master slave elections. So in database description, it is a packet, right? Here there are fields. You will see MTU. MTU by default is 1500. And what is that? MTU means maximum transmission unit. It means per transaction, it will send maximum 1500. See, there are so many packets here. If you open any packet, the maximum 98 bytes. So it cannot be more than 1500 here. Understand? Per transaction. Maximum how much data it will send? 1500 bytes. Okay, that is called maximum transmission unit. And MTU is 1500, and you will see I bit, yeah, initial bit, more bit, and MS bit. Ignore I bit, M bit, and now concentrate on MS. MS bit is equal to set to 1. So it means it is a master. If it is set to 1, it is a master. This is a DBD packet. Same thing it will set here as well. Okay. The thing is in Xstart state, database synchronization process will start so that master slave elections will happen. So initially both the routers are announcing themselves as a master. If how it will announcing the master, if ms bit equal to 1, it is master. If ms bit equal to 0, it is slave. Now both are announcing I am the master, I am the master. Okay. Now here you have, this is dbd packet. Top of that you have a router id, right? I mean OSPF header. You have a OSPF header and then dbd packet. Is it clear? Hello. So is it clear, guys? So OSPF header. So the hierarchy is top of this. You will see a IP header as well, right? Yes or no? IP header and IP header carry payload is OSPF header, and internal it is having a DVD header also, DVD packet. Okay, this is our thing. Okay, now both will exchange these two. So in OSPF header you have a hello packet, right? In that hello packet you have a router ID. What is the router ID here? Sorry, not hello packet. It's in OSPF header you have a router ID, right? Router ID field. What is the router ID field here? 1.1.1. Okay. Yeah. And now here it is the same. It is 2.2.2. Okay. Yeah. Now guys, please understand. So both the routers will start exchanging database description packets. Okay. Now this will exchange. Now on what basis who will become a master? Simple. Whoever having the highest router ID, that will become the master. So R2 sending a this DBD packet to R1. Okay. Immediately what R1 will do? Okay. Your router ID is big. So let me announce myself as a slave. So it will announce MS bit to set to 0. Is it clear, guys? Understand?
Yes.
Sir, I and M, can you please explain that one
No, not required.
once again?
Ignore it. Please ignore it.
Okay,
It's not required.
okay, okay, okay.
Okay. Yeah. So talk about only MS bit. Okay. MS. Because if I
Okay,
want
fine.
to go complex technical way, you cannot understand. So later in CCNP we can discuss. Okay. So this is MS bit. MS means master slave. Okay. So initially both will announce himself as a master by setting MS bit equal to 1. Okay. So R2 will send a DBD packet to R1. And now R1 sees uh, R2 router ID is 2.2.2. Okay, R2 will be the master. So first who will announce? Clay will announce. Okay, you are the highest router ID. You are having the highest router ID. Let me announce myself as a slave. So immediately it will announce himself as a slave. MS bit set to 0. Is it clear, everyone? So now it is 0. Okay. Now guys, very important thing I want to tell you. If you go to any supermarket, you purchase some groceries. How you will carry those groceries? Carry
Bag.
bag?
Bag.
Yes or no? Carry bag, right? So the carry bag will carry your groceries. Okay. Now, similar way, here groceries are routes. Here, those groceries called here routes. How the routes are carried in OSPF? Who will carry this OSPF? Sorry, who will carry these routes in OSPF? Link state advertisements. What is that? LSAs. Is it clear? LSAs. What is that? Link state advertisements. Okay? Link state advertisements. Is it clear? So it is called LSA. So you have lot of LSAs, types of LSAs. We have lot of LSAs. It means lot of people can carry lot of different types of updates. So some people, I told you right yesterday, inter area routes. So that inter area routes carried by separate LSA. Like if you purchase a rice bag, rice bag comes with a pack like plastic, right? And if you purchase a vegetables, you will carry those vegetables in one bag. If you purchase hard items, you will carry in another bag. Yes or no? Each item you will carry another different bags, right? Yes or no? Generally, same here. Different routes will carry different LSAs. So today I am going to discuss about the first LSA, type 1 LSA. This type 1 LSA is called router LSA. Okay, this type 1 LSA is called router LSA, guys. Important thing, remember it. So type 1 LSA is a called router LSA. What it will carry? It has two fields. It's a LSA packet, right? It has two fields. What are the fields? Link state ID and advertisement router. Okay. What do you mean by link state ID? It's a route. It's a route. So this is a syntax of, it means it is a format of LSA. So link state advertisement is a packet. In that packet, you have only two fields. What are the fields? Link state ID and advertisement route. Link state ID and advertisement router. Link state ID and advertisement router. Important. That's why I'm telling you multiple times. గైస్ అర్థమవుతుందా? ఈ రౌట్స్ ని క్యారీ చేసేది ఎవరు? ఎల్ఎస్ఏస్. ఎల్ఎస్ఏ అనేది ఒక ప్యాకెట్. ఓఎస్పిఎఫ్ యొక్క మెయిన్ ప్యాకెట్. ఓకే. సో ఆ ఓఎస్పిఎఫ్ రౌట్స్ అన్ని క్యారీ చేసేది ఎవరు? ఈ ఎల్ఎస్ఏస్. ఈ ఎల్ఎస్ఏ అనేది ఒక ప్యాకెట్ కాబట్టి దానికి ఒక ఫీల్డ్స్ ఉంటాయి ఇంటర్నల్ గా. రెండు ఫీల్డ్స్. లింక్ స్టేట్ ఐడి అండ్ అడ్వర్టైజింగ్ రౌటర్. లింక్ స్టేట్ ఐడి అంటే ఏంటి? ద రౌట్. వాట్ ఈస్ ద రౌట్? ఇట్ ఈస్ ద ఐటమ్. Okay. So here the type 1 LSS will carry loopback IPs 1.1.1.1. This is a IP. It carries 1.1.1. And who will generate this type 1 LSA? Here router 1 is generating. Router 1 is generating type 1 LSA. Hey, I have 1.1.1 route. Take it. So it is telling to R2. Hey, I elected, right? I'm the slave. So let me give my data to you. So in my database, I have a type 1 LSA. It is called, I have 1.1.1 IP and I'm giving to you. So who is generating this type 1 LSA? R1. So what is the R1 router ID? That's it.
One.
So a lot of people will confuse. Hey, link state ID is 1.1, advertising router ID 1.1.1. No problem. Link state ID is the route, advertising router is the name of the router. Suppose here if you configure loopback IP address as 10.10.10, right? Now what is the name of the router? 10.10.10. Now what is the advertising router will be here in case if it is 10.10.10? It will be 10.10.10.10. But the link state ID, the route will be the same. Guys, you understand the difference what I'm saying here?
Yes, sir.
Everyone?
Sir, advertisement router means the highest loopback ID, right?
No, advertising router means router ID of the router, the name of the router.
Yeah.
It could be anything.
Okay. Okay.
Okay.
Yeah.
Advertising
Okay.
router means the name of the router. Who is generating this LSA? Who? R1. And his name is here. Okay, understand? This is all about advertising the routes. OSPF, how they will advertise the routes, how it will carry the routes through link state advertisements, LSAs. So these LSAs will carry the routes. Now type an LSA, the type an LSA, router LSA, it will carry the loopback IP. Okay, it will carry the loopback IP and it will send to R2. Is it clear, everyone? Hello, hello.
Yes,
Is it
sir.
clear or not? So first they will
Yes, sir.
discover the neighbors. After discovering the neighbors, they will start exchanging DBD packets to synchronize the database. Since who want to exchange the database first, they are fighting, right? Both the routers will announce themselves as a master. After exchanging the DBD packets, they will come to know who is master and who is slave. The slave first set MS bit to 0, so it is slave. Whoever having the highest router ID, that will be the master. Lower router ID will be the slave. Slave will announce first and it will start sending. R1 is start sending its database information. In its database, it has a type 1 LSA. Type 1 LSA means a router LSA. These LSAs are the main important things to carry the routes. So which route the type 1 LSA is carrying? The loopback IP. The type 1 LSA is carrying the loopback IP. This R1 is connected to another routers also. It could be another area. So another area routes will be carried in different LSA and sent to R2. So different items you will carry in different plastic covers, right? Same here. Okay. So first it is a router ID. Okay. Same way. So immediately it will send. So in extort state, what will happen? DBD packets can be exchanged and they will elected master and slave, and once a slave is elected, it will start sending a type an LSA. Same thing. Same thing it happens in R2 also. I'm not going to explain here, but same thing it is happening in R2 also. So once it is start sending type 1 LSA, right? After electing master and slave, okay. Once it start sending type 1 LSA to R2, immediately it will move to the exchange state. In exchange state, both the routers are will exchange the type 1 LSAs first. Okay. Here, what is the type 1 LSA it will exchange? Can anyone tell me what is the type 1 LSA it will exchange here?
Two dot two dot two dot two.
Yes.
Advertising routers to
So it will be 2.2.2 here. So link state ID will be 2.2.2 and advertising router ID will be also 2.2.2. Is it clear, everyone? Is it clear here?
Sir, advertising router will be same all time, right? If it
So
is
yes,
multiple routes which
multiple
need
routes.
to
You
exchange,
absolutely, man. Superb. Yes. Even if you're carrying a 10.10 route, 100.100 route, whatever the routes will be changed. Routes will be added here, but advertising router will be the same, the name of the router. Yes. Okay. Yeah.
okay.
Okay. And this will be like this. Okay. Yeah. Now, in exchange state, both the routers will exchange this, type an LSS and move to loading state. In loading state, now two sons responsibility is complete, right? This other three sons. Now here it will come. Link state request, update, acknowledgement. See here. Now these three sons, like link state request, it is a link state request. What does that mean? LSR means what? Link state request. So what will happen, hey, we both exchange initial routes, loopbacks. So in case in your database any missing information, it means, hey R2, you may connect it to another routers, another OSPF routers, maybe in different areas. So definitely you will have the database with another routers. So in case if anything there it is missing in your database, right? Please send me. You just only sent loopback type an LSA only. So if you, another type of LSS if you have, right, please send me. So this link state request will be sent to both R1 and R2. Both will Both the routers will both the routers will request it, link state request. R1 send link state request to R2, R2 will send link state request to R1. Now, once they receive a request, yes, hey, yeah, I have a update. Please take it. In update message, it will update with all other LSS. Once the update is received, they will acknowledge. Link state, acknowledge. So once this is done, right? Acknowledge meant. So once it is done, they will go to full state. Now database is synchronized. Now it go to full state. Now what will happen? It will run a Dijkastra algorithm, calculate a best parts, put in routing table. Is it clear? This is called OSPF adjacency process. How many states we have? Down, init, two-way, extort, exchange,
Seven.
including full state, 7 states. And in each state, what exactly will happen, you know, right? Everyone, please prepare well. Okay. Now, can I explain one more time by configuring this? I mean, by doing packet capture. So same thing, whatever we
Sir.
discussed theoretically. Shall I show you practically, guys? Hello.
Yes.
See
Yes,
here.
Yes,
sir.
sir.
Now OSPF I have already configured. See, 1.1 is sending a hello packet to through multicast address. 1.2 also sending multicast. See, both the routers are exchanging hello packets each other. See here. So 1.1 sending to multicast address 224.0.0.5. See, source IP address is 1.1, destination address is 1.224.0.0.5. And now in OSPF header, see it. So this is what we discussed, right? Version, router ID, okay, and area ID, authentication type and data. Yes or no? These are only things we discussed, right? Hello, authentication type and data.
Yes, sir.
So see this. This is the only thing, right? Same way. Source IP is 1.1, destination IP is 2.0.0.5. So OSPF header C, version 2, router ID, OSPF source OSPF router means router ID, and area ID and authentication type and data, right? Area type is also there that we can learn later. Okay. So now see it. Both the routers exchanging hello packets and see the parameters are matched. Is the parameters are all are match here? All are same, right? And so router ID also unique, right? Yes or no? Hello. Can you check the parameters, right?
Yes.
Both routers having
Yes, sir.
same parameters. Then immediately what will happen? See immediately. See See, immediately what will happen? 1.2 is recognizing you are my neighbor. See, in hello packet field, there is active neighbor field. See, R2, 1.2 means R2. R2 telling that, hey, you are my neighbor. Similarly, R1 will also tell you. See, both the routers announcing themselves as a neighbors. Yes or no? See,
Yes.
right? Here, see, R1, 1.1 telling that, hey, you are my neighbor. 2. It is entering 2.2.2. So R2 1.2 entering 1.1.1 in active neighbor field, they enter neighbor router ID and exchanging it. Now here neighbors are discovered, right? The neighbors are discovered. After discovering the neighbors, they'll see the black colors. They will exchange the DBD packets. See here, 1.1 is sending a DBD packet. It is a unicast now. See 1.1, 1.2, unicast, not multicast. Okay. In DBD packet, what you will see? MTU 1500 and MS bit set to 1. See, R1 is saying that I'm the master. Similarly, R2 will also say that same. See, R2 is also saying master. I'm also master, right? See, both are setting master master. 1.1, sorry, this is also 1.1. So yeah, so this is 1.1. 1.1 saying I'm the master. See, 1.2 also saying I'm the master. 1.2 means R2 is saying I am the master. 1.1 means source here. Source 1.1 means R1 is saying I am the master. So both the routers announcing themselves as a master, right? So after exchanging these packets in OSPF header, router ID will be there. So after comparing that, so first who will announce? R1 will announce as a slave. See it here. R1. See, R1 is announcing as a slave. See, set to 0. You're not master. After announcing himself as a slave immediately, it will start advertising type 1 LSA. See here, right? It is start advertising type 1 LSA. It is announcing slave immediately type 1 LSA you see. Yes or no? Router LSA. Same thing I have discussed. Hello?
Yes.
Right? What is the link state ID here? 1.1.1. Advertising router ID will be 1.1.1. Okay? This is the information it will send to R1. Similarly, once it is done right, guys, are you following me? Similarly, 1.1
Yeah.
Yes,
announcing
sir.
as a slave, 1.2 will be the master. Once it became master, it will also advertise its type 1 LSA. Now exchange state is completed. In exchange state, both are exchanging initial type 1 LSAs. So now what will happen? Loading state will happen. See, loading state you can see here. Link state request, updates, acknowledgement. Are you seeing it? Link state request, update, acknowledgement. Are you seeing it?
Yes, yes, yes,
Yes,
sir.
sir.
So this is called loading state. Once the loading state is done, you will run, move to full state and it will run the algorithm and see both the routers will have the same data you want. Here, here, here I am. Okay, here. So what is the command to check the database? Show IP OSPF database. First of all, check the neighbors. Show IP OSPF neighbors. So neighbors are discovered. Now show IP OSPF database. See, this is a database of R1. Now this is a database of R2. Check the database. See, this is R1, this is R2. Check the database. Show IP OSPF database. Right or no? Okay. Max. See, this are you seeing it? Hello. Both are in having same database or not? See. Hello. You're not seeing my screen.
Sir, your voice is
Voice is
breaking
breaking.
for
Sir,
me.
your voice
I
is
don't
not
know.
clear.
Okay, can you hear me now? Hello.
Yeah.
So
Yeah,
I'm
yes.
Yes,
saying
yes, yes.
both the routers are having same database, R2 and R1. Please check it. Same or not? Now it is syncing, right? Synchronization is done. Both the routers database is same. Yes or no? Hello,
Yes, sir.
Yes, sir. Yes, sir.
right?
Yes,
Yes,
sir.
So
yes.
the database same. Now it will run the algorithm. It will calculate a routes in routing table. See, now you will see O. O means OSPF. Okay, this is a process at the back end. Okay, please watch this video again and again and again and prepare your own notes. I had a 7 years of experience, but I was not aware of it when I was working. After joining in a tech environment, I learned everything at packet level. Now I'm delivering to you here. Understand? Since you're a freshers experience, don't worry. You cannot learn everything on a single day. You cannot remember also. But at least during class are able to understand what I'm saying, right? So it makes some sense, right? If I'm saying anything. So if you understand that, watch the recorded session on this complex stuff and prepare your own notes and learn it. Okay. So open your mobile phone and start explaining the states by yourself and improvise it. That's what I did it. Can anyone guess how many months I have taken to complete? How many days I have taken to complete OSPF? Can anyone guess it?
One
Hello?
year.
10.
Not 1 year, man. I took 3 months. I took 3 months to complete all the OSPF. Even though if anyone asking, can you rate yourself in OSPF? I'll rate myself as a 6 only. Okay? Yeah. That's all for today, guys. Thank you.